पास में इसको कर लो ना ताकि आप इजीली कर पाओ, या इसको रख लो, इससे भी हो जाएगा. So I am from Bio Consultant, Managing Director of this company. We have started recently. Before that, I am working for the other company. Our 5 mantras of Bio have 5 letters. So Bio is be kind with nature. Of course, you are. Improve the environmental condition, overcome the pollution potential, hope for the best, and do the things at very first time, and manage the environment to protect the earth. These are the 5 mantras only, and as thought process next. And this company has started last year with the thought process of the environmental consultancy for sustainable nature. Next. These are the values. Next. Policies towards the environmental consultancy and engineering solution. Next. And these are the services of our company, including environmental clearance, forest clearance, wildlife clearance, green building certification, water audit, CGW permission, infrastructure development, carbon credit scheme, risk assessment, modeling, and farming. Now, exact scenario that is advances. How this term came? Why we are talking about water? We are concerned about the water. Reason, you can see this is very recent article published in the Times of India. That surface water availability fell by 8%. You can assume 8% is what? Because whole of that in Narmada basin during the last 65 years. That means day by day water is depleting. Why? Because this is natural resource and we are consuming, and we are not consuming only. We are what? We are polluting that, which cannot be returned again to that river or those rivers. Next. So, in the current scenario, water is so important because we are living entity, and we are means any living entity cannot be sustained without water, without a drop of water. And you can assume all the industry, even fabrication industry or manufacturing industry, all industry are using water as a main prime source, because in case of chemical manufacturing industry, they are using huge water, and in distillery industry, they are intensive water use industry. So the current scenario, nearly 62 billion liters per day sewage is generated per day in India. This figure is for this country, and while about 23 billion liters will be treated. That means not less than 50%. That means we are polluting more than 50-60% water, and which cannot be returned back. Over 6.6 billion people in India lack the sanitation facility. Now Swachh Bharat toilets are prepared and all, but till now this is actual scenario. आप गाँव में जाएंगे देखेंगे वो लोग यूज ही नहीं कर रहे. अगर कहीं टॉयलेट बना भी है, they are not using it. So as per the report of groundwater in India, this is depleted about 10 to 25 millimeter annually. And in rainwater, you can see, in case of summer season, summer cropping season, this is about from 1050 to 1000 mm only. And in case of winter, the decline from 150 to 100 means about 50 millimeter rainfall has been depleted. Any rainfall become more natural resource को utilize करके return back भी नहीं दे रहे. So this water is exactly polluting day by day, and concentration means amount of water pollution is increasing day by day. So as per the recently released water management index, NITI Aayog, you can see on website also, was water crisis, and more cities like Delhi and all, they can be crisis run out by 2020, means next year only. Next. That is the current scenario of water. You can assume if suppose for one day, like आप लोग व्रत करते हैं, fasting करते हैं, in that day also we take water in the evening and night. Suppose 24 hours we don't take water, then what will feel exactly? क्या होगा हमारे साथ? Then you can assume exactly for water for that living entity living in the run of Kutch area जहाँ पानी बरसात भी नहीं हो रही है, and in the desert area. So So yes, industrialization of Gujarat. You can see in Ankleshwar also number of industries are there, and the Ankleshwar city is under critically polluted area. Again, safety index more than 70. What is safety index? Anyone can say about safety? CEPI. This is pollution index released by CPCB, Central Pollution. Yes, New Delhi. That yearly safety index has been released on the basis of air only. From this year, they have included water and land pollution also. On that basis, Surat is under critically polluted area. On that basis only, on the basis of air quality index, Surat is not, but on the basis of water, because Surat has more than 4,000 textile industries in time building, and they are using only water and polluting water and then disposing without treatment. So water pollution is more than this Ankleshwar area and Surat. So Surat has been under more than 70, that is critically polluted area. And now NGT has imposed a condition for 3 months, all the industries should be shut down and no new industry to be released from the GPC. Next. Status of CETP. Why CETP? Because ETP, that is different treatment plant, CETP common. In your this area is Ankleshwar GIDC, and any GIDC have CETP, common effluent treatment plant. So that and common effluent treatment plant for designed for a special type of like chemical, then only designed for chemical industries. So this is the scenario. Ahmedabad has 11. Vadodara has 12, Bharuch has 3, Surat has 7, Valsad 2, Junagadh 1, Rajkot 5, Gandhinagar have 1, and Kutch has only 1. Jamnagar will close there next. So now, what is the water pollution exactly? Well, simple definition is any undesirable changes in the water quality is water pollution, correct? But some contaminants are there. One is suspended solids like TSS. Some nutrients, phosphorus, nitrogen, some priority pollutants, and refractory organics like COD and BOD, some heavy metals like chromium 6, chromium 3, hexavalent chromium is more dangerous absolutely. Some dissolved inorganics next. So these priority pollutants are like heavy metal, you can say arsenic, and this arsenic is more dangerous when it is in drinking water. A case study from West Bengal. The wells of West Bengal have arsenic only, and the people have used to drink this contaminated water. And after some time, because this is heavy metal, of course under heavy metal, chromium, cadmium, lead, mercury, zinc, and many more. Like arsenic and chromium, hexavalent chromium is also toxic. So these heavy metals, if found in the water, that means there is a danger for the drinking. Pesticide. We are using pesticide in the agricultural crops. So that can be not degraded. They can be enter into the groundwater and contaminate the groundwater. Polyaromatic hydrocarbons, and one is PCBs. Next. So as per definition of USPA, have 6 attributes of water pollution. In short, we can say biodegradable waste, plant nutrients, and one factor is heat. In case of thermal power has released huge amount of hot water into the sea or into the cooling something, and hot water means temperature of that water is more than ambient temperature. Then the flora and fauna in that water can be degraded. Sediment, hazardous and toxic chemical, some radioactive that include wastewater discharge from the factories, hospitals, or some uranium mines. So that can be also dangerous for the drinking water. So now, how we can treat that water, that wastewater? Because our intention for today is only wastewater technology. So हमने उसको थोड़ा brief में किया. One is preliminary. Preliminary means we have to just segregate the big particles. Suspended and something उसको नहीं करना. Big particles like पहला है हमारा screen chamber, screening of that. कहीं पर भी कुछ ट्रांजिट टाइप का particle है or something, so we can screen out. And some heavy suspended solid can be separated by the grid chamber. That is preliminary. Second one is the primary treatment. Primary means first actually. That means in case of chemical processes are there like coagulation, flocculation, sedimentation, lab system, dissolved air fluoridation, clarification, crystallization, precipitation. Primary clarifier reduce about to 70%, 70% of the soluble saturated particle. And in secondary, that is some biological processes, volatile insoluble organic matter can be treated in this. And tertiary treatment, some impurities, if we cannot treat by secondary, then we need tertiary, some biological treatment also. Next. There are some conventional technology which you have studied, like one is ASP, and second one is membrane bioreactor, moving bioreactor, amphibian. These are the conventional technology which is used by all consultants. Sequencing SBR, sequencing batch reactor. So in case of MBR and amphibian, they are simple type, but in case of amphibian, that is moving bioreactor, and amphibian is only means fixed bioreactor. Next. These are the pictures like ASP, amphibian, MBR, and SBR. So that can be seen at any type of. Basically, in case of STP, nowadays MBR is most preferred conventional technology by all means treatment methods. This is treatment. Next. Treatment is grid chamber and all. Next. Hydraulic diagram, any of STP. And now, what is the need of advanced technology? Now come to this our topic, that is advances. So see, for the conventional technologies, we feel that some operation cost is more higher at site, and the quality of treated wastewater cannot be reused in many cases. In case of SBR, MBR even, these technologies do not make wastewater fit. Actually, they cannot be given for drinking actually, but the treated water from the conventional technology can be used in gardening or cooling tower if industries there. So, and having some pollutants. So now the requirement of the application of innovative and cost reduction. Conventional technology has first drawback is they require a huge amount of land. Now you can see in any city, traffic is the main problem. Why? Because any building has not adequate parking inside that building. Reason, there is no land available. That means land is most important. And again, STP or any type of treatment equipment is non-productive for the industrialist. Why? क्योंकि उनको वहाँ से पैसा नहीं मिलने वाला. Productive and non-productive is what? Productive means any type of manufacturing, any type of activity which can give money. लेकिन ETP money नहीं देता उनको. So that is the reason. And दूसरा कि एक जमीन बहुत ज़्यादा खा रहा है, means they require a huge land. Conventional technology कोई भी देख रहे हैं, they require a huge land. And land is not available for this type of. So there is major two factor. One is the treated water quality is not good as per CPCB standards. And second one is that they require huge land. Other is advanced technology are used to break down that complex contaminants like cyclic aromatic or cyclic compounds which cannot be treated by conventional technology. So we need these advanced technology. Next. So what type of technologies are there in market? Some of them, one is automated chemostat treatment. We'll discuss later on. And one is soil biotechnology, especially for STPs, sewage treatment plant. And this is patented by IIT Bombay. And again this is reed bed technology. Reed bed is also known as root zone technology, in which we use common reed plant, that is wetland plant especially, type of murium and some other. Hydrodynamics cavitation, especially for refractory organic pollutants. And one is wet air oxidation. And some advanced oxidation processes are there. Electrochemical technologies and electrochemical advanced oxidation process. Now we will discuss about in detail automated chemostat treatment technology. What is this? This is the novel technology, specially treatment of sludge. Sludge, you know, I think. After treatment of from any ETP or any STP, we have sludge. That is semi-liquid, we can say, having more than 90% moisture and some content of organic, inorganic. Like जो भी आपने treat किया है in terms of BOD and COD, suspended solids, they can be in sludge. So the scientific concept behind this ACT, that is automated chemostat treatment technology, is the use of appropriate bacterial cocktail, because we need to treat the sludge, and sludge have organic and inorganic. Inorganic in the term of like heavy metals. So we need appropriate bacterial strain to degrade into simpler compounds. That is known as chemostat process. You heard about it. I think आपने किसी syllabus में कहीं पढ़ा हो chemostat and chemical engineering. The process is maintaining an imbalanced state of bacterial growth. When we introduce the bacteria into any type of media, they have to grow and they have to multiply within 24 hours. Double. कोई भी bacteria E. coli or something लेते हैं, so they will be means they have a fast reproduction within 24 hours, and they have a logarithmic phase, progressive. The process in chemostat reactor, independent of FM ratio, COD, BOD load also, and this can be controlled through a control system, automated control system, there is, which help overcoming of COD shock, because COD control the system, so we have to control before that COD shocks are there. So biomass recycle is not required for this process of chemostat operate, because it operates at low biomass concentration, that is MLSS, which is around about 100 to 400 ppm, and this depending on the organic load of that sludge. Due to low concentration of bacteria, no aggregates are formed, and these bacteria which is introduced into the system act as single unit, increasing the surface area available and achieving optimal biological biodegradation of that organic matter available into the sludge. Next. So this chemostat process, you can see here a representation. So the input from the means after ETP or STP, that is sludge, into the bioreactor, and bioreactor has a specific bacterial strain which is designed for degradation of that specific type of sludge. How and why? Because we need to degrade that compounds. So we have, before going to fill the sludge into bioreactor, we have characteristic of that sludge, like inorganic कितना है, organic कितना है, and which type of organic matter inside the sludge. As per that characteristic, we have to design the bacterial strain. We have to choose, not design exactly, because in the market they are on the basis of your characteristic, the bacterial strain is available. So we have to choose the bacterial strain, and then we have to maintain the chemostat process. And then there is a graph also, you can see. When we input the sludge, the graph will show like that, the bacterial growth, and when after 24 hours, because you know the bacterial growth is very fast and they can double in 24 hours only. But we need to control two things. One is pH and second one is the temperature. Okay. Next. So what are the feature of that chemostat technology? This chemostat technology is actually reactive biospheres, and this eliminates the requirement of DAP process. DAP process is what? Dissolved air flotation technology. Output can be means sludge free can be deposited directly in the nature by reducing biosludge, handling and creation of black sludge. This technology output meet the standards of CPCB, GPCB and all, even this WHO. And this offered highly effective treatment of side stream. Also implemented without adding the additional treatment technology, because in previous slide, back slide. In this you can see we need a simpler this design is very simple. We need to add the sludge into the bioreactor, and we have chosen one bacterial strain as per the characteristic of the sludge. We have added into the bioreactor, and then we need to wait, means we need to control two things, only two things. One is pH and another one is temperature. Why temperature? Because after the reaction of the production of, means reproduction of the E. coli, temperature will increase. So we have to control or set at optimum temperature, which require bacterial growth in the logarithmic phase. Next. So the bioreactor can be applied on site. Means you can take this bioreactor, and this is very simple in design and small in design in the size of. So you can take it at site also with high flexibility in modulation. This is green process. We can modify as per the requirement, like oil refinery, oil storage farm, oil drilling, marine ports, and some other contaminated reservoir storage tank. Means this chemostat process can be utilized especially in oil treating, oil refineries, oil industries, because their bacterial applications are there. So they can remove heavy metals, they can remove any oil contaminant from the sludge. Next. So what are the benefits of this chemostat technology? One is low cost, low actual concentration, no recycling is required of that sludge. Sludge wasting period equals the bioreactor retention time. So we can equalize all those. Means we don't have to take to wait for the treatment. This can be sustained, and any type of COD fluctuation from 4,000 to 40,000. This can react fast because multiplication is only 24 hours. Then the lower cost operation, simple automated control system as per design. You can virtually sludge free, meeting all disposal standards, easy to modify, and the limitation is only because this depending on the COD load. So we have to control the COD load. Next please. So now we'll discuss about soil biotechnology. Soil, as I say, this technology is patented by IIT Bombay and named as soil. Why? Because media is soil and bacteria. So after 20 years of research in IIT Bombay, they have patented this technology, and this is very good technology, but having some limitation. Of course, all conventional technology have more limitation. This is having some limitations because this again require a huge land. The soil biotechnology ensures, and also this control order nuisance first in case of STP. Using bacteria, earthworm, mineral additives like garden setup. In this system, combination of physical processes like sedimentation, infiltration, biochemical processes are carried out to remove the suspended solid, organic, inorganic contaminants from the sewage. This is suitable for mineral constitution. Microflora, bioreactive plants are the key components of this, and it is also known as CSF, like constructed soil filter, that is natural soil filter. This system constructed in RCC, masonry, soil burns also, consists of raw water tank, bioreactor, contaminants, treated water tank, piping and pumps. This enforces the carbon and nitrogen cycle in nature. So quality of treated water exceeds our state pollution control board, reducing the COD and BOD, and can be used for gardening purpose or any other, like in case of your flushing, bathing even. This water treated from SPD technology can be used for bathing purpose also. Except drinking, this water can be used anywhere. Next. Here is the representation, SBT, how we can design the SBT. Life of specially constituted filtering media like soil bed. Since in the time of natural living agent multiply, a strain to the optimal level based on the actual chemical and biological load. So treated water can be used in gardening, washing yards, except water drinking we can use anywhere in industry. And NDMC Delhi is using this water after treatment of from this technology. We have installed 12 STP in Delhi area only, Lodi garden, to treat this water, to treat the sewage, and they are taking back for their purpose, gardening and other flushing purposes. Next. One picture from Mumbai Municipal Corporation. You can see, you cannot imagine there is STP working because this is the outlet. You can see there is no any open area. Whole system is closed, and the above side is upper side. You can see the plants only. This is the STP, SBT base, because soil is a media itself. Concrete is 3 layers of the media, concrete and all, then soil and bacteria, earthworms. That is natural system. Filter that water and then we can reuse without using of ACF, PSF, any type. ACF means activated carbon filter. PSF, pressure sand filter. Means any type of filter is naturally working here. जो हम means naturally artificial design करके बनाते हैं. So we have designed, IT Bombay have designed this type of the appearing type of garden, simple garden. We cannot see exactly by first impression the working STP, and there is no odor nuisance. जैसा कि दूसरे STP आप देखते जाएंगे तो नाक बंद कर लेंगे, but in this case अगर हम फ्लावरिंग प्लांट लगाते हैं, पावर का silent feature of that. Most important feature is there is no sludge. Why? Because the soil media itself, sludge has been deposited in that soil only, and after 20-30 years we can remove that soil and use in the as a manure, fertilizer. And this is continuous mode. We can make a batch also, but optimum working is continuous, 24 hours. Mechanical aeration is not required. No any mechanical agitation, aeration, and nothing. Overall time is about 6 to 7 hours to complete one cycle, and then this water recycle again. Advantage is life of filtering media is very long, more than 10 years. Power I think.